All right, so objective number 1 says we're going to find the exact values of sine, cosine, and tangent of theta in standard position if point Q is on its terminal side. So the instructions look a little bit unfamiliar here, but we do know what terminal means, and that means the end of some angle. And we know point Q is on the terminal side. So there's going to be a couple formulas. You should recognize the problems here. Of course, they give you an X and a Y, but it's an unfamiliar X and Y, so it's not one we typically see on the unit circle. But we're going to do a throwback. We're going to use these formulas for sine. Of course, sine is O over H, but you might remember when we first started talking about the unit circle, sine is actually Y divided by R. Cosine of theta is X divided by R. Again, we usually left the R part out because with the unit circle, the radius is always 1. But you're going to find with these problems, since the X and Y coordinates have been scaled by a certain factor, the radius has as well. So we got to figure out what the radius is to come up with these exact values. And of course, we know tangent is Y over X. So letter A, we're going to sketch the point 3, -4. That, of course, is going to be in the 4th quadrant, so that's right 3 and down 4. And that's on the terminal side of some angle. Overall, that's not an incredibly important part of this problem. What we're actually going to do, instead of focusing on the angle in this problem so much, is we're going to draw a reference triangle. So that's going to be a vertical line straight to the x-axis. And of course, this little angle right here is our theta. That's the reference angle that we always use. Now we know this problem, the x-coordinate is 3. So that's our horizontal distance on the triangle. The height of that triangle is -4, and the radius is what we have to determine. But of course, if it's a right triangle, and we have 2 sides of a right triangle, we can use the Pythagorean theorem, which in this case is just, instead of a squared plus b squared equals c squared, it's x squared plus y squared equals r squared. When you get to pre-cal, this is actually the form they use instead of a squared plus b squared equals c squared. But of course, just the same thing. So 3 squared, make sure if you do this in the calculator, you put -4 in parentheses. And hopefully from your geometry days, this might be one you just have memorized. So we get r squared equals 25, so the radius is 5. And now we can figure out sine theta. Sine is y over r, so we already know the y coordinate is -4, and the radius is 5. So that's our exact value for sine. Our exact value for cosine is 3 over 5, so that's x over r. And tangent is y divided by x. And the last thing some of these problems may ask you to find, that it may ask you to find actually what theta is. So it wants to know what is that reference angle. So you can find that using inverse trig pretty quickly. And you can do any of the trig functions. So if you hit second sine and type in -4 divided by 5, you get -53 degrees. Now, since it's a reference angle, technically it's positive 53 degrees. But you'll notice if you use inverse cosine and inverse tangent when you type it in, you get either 53 or negative 53 for all of them. So if theta is 53 degrees, then we can figure out what the measure of that big angle is. The measure of that big angle is 360 minus 53, 307. Objective number 1, though, right now is just asking for the exact values for sine, cosine, and tangent. So negative 4/5, 3/5, and negative 4/3. Encourage you, pause the video, try to start B, go as far as you can. Here in about 10 seconds, I'm going to start working that one out. So that's what the sketch of the triangle should look like. You'll notice I didn't make any tick marks, but I do know the x-coordinate is -3, so that's the left to right distance of the triangle, and the vertical distance is -6. So the work to find r, remember the form is x squared plus y squared equals r squared. So we're going to get r squared equals 45. So we're going to get, when we take the square root of both sides, we're going to get radical 45. We do not want to type that in the calculator. Instead, we want to make a factor tree and break down radical 45. That should simplify to 3 radical 5 as our r. So we know r. That's not our answer, of course. Let me not circle that, actually. We know x, and we know y. So we should be able to come up with our 3 trig functions here. So sine is -6 over 3 radical 5, which reduces to -2 over radical 5. Rationalize the denominator, is going to give you -2 radical 5 over 5. So that's sine. Cosine is going to be -3 over 3 radical 5, which reduces to -1 over radical 5 when we rationalize the denominator. That's going to give you negative radical 5 over 5. So that's cosine. And then tangent's much quicker because there's no radicals for tangent in this case because it's y divided by x. So that's just -6 divided by -3 is +2. So that's the tangent value. I'm going to pause the video and try the your turns at the bottom, and I'll reveal those answers here at about the 9-minute mark. All right, so there's the work for part A. You should notice, if you did do inverse trig here, which you don't have to, that angle is 45 degrees. It's a 45, 45, 90, since x and y are the same. So that tells me cosine and sine are going to be the same. So that's why I only have the calculations there for cosine theta. All right, and then here's the answer for part B. Should have seen some familiar fractions. Did one pretty similar to that earlier. So there's your answers. All right, and the last problem. So this time they give us some information about theta and its terminal side being in the third quadrant. They want us to find the exact value of cosine theta if sine of theta equals -3/5. Now we know the radius is always going to be positive, because to get the radius you have to square x and you have to square y and you add them together. When you square a negative number, as you saw earlier, it always ended up being a positive number. So the radius is always going to be a positive value. So when they say sine equals -3/5, remember sine is y/r. So this is the y value that is negative, not the r. And that should make sense, of course, because we're in quadrant number 3. In quadrant number 3, y is negative. So when we sketch this triangle, we know the y-coordinate is -3, so we're going down 3. And we know the radius is 5 units. We're just estimating here. It doesn't really have to be drawn to scale. And we don't know what the x-coordinate is. And of course, my theta is the reference angle there, right at the formed at the x-axis. I actually drew that triangle wrong. It should be oriented this direction. But now we're working backwards. Pythagorean theorem. Should be comfortable doing this. So the formula is x squared plus y squared, which we know equals r squared, which we also know. And again, this should be one of those triangles you're pretty familiar with. It's ultimately end up being a 3, 4, 5 triangle. Take the square root of both sides. Or when you take the square root of 16, it can technically be 4 or -4. But since we're in quadrant number 3, x has to be -4. It's all about what quadrant we're in. So now the question says determine cosine of theta, and we can do that pretty easily. Cosine of theta is x/r. So that's just -4/5. And then the final part of this wants us to determine theta. So we're going to use inverse trig to determine theta. Where theta is represented as a reference angle. So it should be positive. It should be less than 90. So I can do second cosine and type in -4 divided by 5 and see what I get and see if it'll give me the answer. It gives us 143. 143 is in the second quadrant where cosine is negative. You could use that to determine the reference angle, or you could try inverse sine. So second sine, -3 divided by 5. And it actually gives me the reference angle as positive 37 degrees. And you could have gotten that from 143. 143's reference angle is also 37 degrees. So theta, in this example, 37. And there's only one answer because the problem said theta is in the third quadrant. So try those last two, pause the video, and I will show you the answers here in just a moment. All right, so here's the answer to part A, and notice I did change the original problem to -1/2, which it should read on your worksheet, because since it's in quadrant number 2, x has to be negative in that quadrant. And of course, y is going to be positive. And I didn't even sketch the problem in this case. You don't really need to, because ultimately we're just using Pythagorean theorem to determine y. And then sine is y/r. So radical 3/2 should be the answer. And then here's the work for part B. And again, notice we're in quadrant 3, so x and y both have to be negative. So I know the very last step, when I take the square root of 1, x is equal to -1. And of course, cosine is the x coordinate divided by the r coordinate.